Algebra 2, Lesson 36. We are going to begin on page 162. We're going to be talking about how to solve problems that look like this, okay? Basically, we have polynomials, and we're going to be multiplying them. And in order, they're actually pretty easy. You just need to know kind of the routine of how to solve them. So in your textbook, 36.1, the problem looks like this. This whole big problem here. Okay, takes up a lot of room, but really you're going to find out that you're going to get an answer that's actually relatively small over here. Okay, so how do we solve these? We noticed, number one, that these four things, these two fractions of polynomials, are being multiplied, just like a fraction. Okay, 1 over 2 times 1 over 2 equals 1 over 4. We're going to do the same thing, except we're going to multiply them. But before we multiply them, we have to do what we call factorization on each of these in order to make sure that, or in order to simplify them. Okay, so how do we factor these polynomials? Well, to get x squared, you note that we get two x's right here and right here. And it excuse me, in every single one of these you have an x squared, so therefore we're going to actually be able to make them x's all the way through. So I've already set it up that way. Okay, so let's focus on this one right here first. Okay, how do we get an x and a negative 12 to show up if we multiply x times something and x times something? How do we get that to happen? Okay, remember that something times something is going to equal this number, and something plus something is going to equal this number. Okay, so I would suggest, if we're going to get a negative 12 and we have a positive x, that we're going to have a negative 3 and a positive 4. What's negative 3 times 4? Well, that's negative 12. What's a negative 3 plus 4? Ooh, that's positive 1, or x. Okay, so let's do the same thing down here. We've already got our x squareds put in. Okay, how do we get a negative x and a negative 20? I'm going to say that to get a negative 20, we're going to have a positive 4 and a negative 5, because a negative 5 and 4 gives us a negative x, and 4 times negative 5 is a negative 20. Okay, let's go over here and do this one. So we've got our x's. How do we get a 35, a negative 35, and a 2x? Okay, what times what equals 35? It's kind of 5 and 7. So we need a negative 5 and positive 7. Down here, a little challenging, we have a 9x and a 14. So what times what equals 14? Well, we have a 2 and a 7, okay, and they're both positive, so we're going to have a positive 2 and positive 7. Okay, now here's the cool thing, is when we get these, we can actually cross out ones that are the same. In other words, we're going to reduce. Okay, so I'm going to do this in a different color. So I'm looking for top and bottom to be the same. So this x plus 4 and this x plus 4, they can go away. This x plus 7 and this x plus 7 can cancel out as well. Look at this. We've got a negative 5 here and a negative 5 here. Both of those can cancel out. So it has to be one on the bottom and one on the top, exact same signs, and look what we're left with. X to the negative 3 and x to the positive 2. All right? Really simple problem. Okay? Now, it's going to be the same system, except some are going to have a dividing sign here. And when that's the case, remember, after you factor this side of x plus something and x minus something, or whatever the case may be, remember, division means that you have to flip it, and then instead of divide, you're going to multiply in order to satisfy that division problem. Okay, so that's the only other example. So go to number 8 in your lesson, number 8, and it has x squared plus x minus 20 over x squared minus x minus 2. That is being multiplied with x squared plus 10x plus 16 over x squared plus 3x minus 40. Okay, now we need to factor them. All right, what are we going to do with this first one? Okay, we have an x and we have a negative 20. So we know that it's going to be x to get the x squared. And because x is positive here, we're going to say minus 4 and plus 5, because 5 times negative 4 equals negative 20. And addition, we get that. Okay, bottom, same thing. I'm going to add our x's in right away. We have a negative x and a negative 2. So I would suggest a positive 1 and a negative 2. Over here, same thing, x, x. All right, we've got 16 and a 10x. So 2 times 8, right? So we're going to have plus 2 and plus 8. And then on the bottom, we have a positive 3 and 40. What should we do here? We got a 5 and an 8, generally speaking. So we need a negative 5 and a positive 8, because negative 5 and a positive 8 equals a positive 3, and those two multiplied equal the negative 40. All right, now all we have to do is start canceling things out. There's the 8s that match. We've got a negative 4 and a positive 5 plus 1 and a negative 2. That's not going to be able to cancel anything out. Okay, so it looks like that's all we have as far as the canceled spots are, so we can't cancel anything else out. So here's our answer: x minus 4, x plus 5, x plus 2, all over x plus 1, x minus 2, x minus 5. That's the furthest we can simplify it. Okay, and the reason is because those positives and negatives, they have to add up in order for us to be able to cancel them out. Okay, so bigger answer here than we did on the last one, but you get the idea of how to factor those out and cancel them. Okay, any questions with that? If not, I think you understand the lesson. All right, so if you have any questions, talk to me and we'll work through them during your lesson. Okay, all right,